Hello, solar installers and dealers across Canada, and welcome to HES's webinar series. Today, we are very fortunate to have with us Daniel Partridge. He is leading the fast rack installs, and he's going to be presenting on planning the perfect install today. For the presentation, if you have questions, please post them in the question section on the side of your control panel. At the end of the presentation, we will be doing a 15-minute Q&A. And really, that's about it. Dan, welcome. Thank you for joining us today.
Thank you very much, Cameron. And thank you to everyone who's attending today's webinar. Just as Cameron just mentioned, we're going to be covering some of the planning the perfect install, particularly the mechanical site assessment and getting all your ducks in a row before and during the start of the install. I'm going to try to go pretty quickly through the presentation. There's a lot of information I want to cover, and as we said, we're going to try to leave some time at the end for some Q&A. If we run short on time, definitely email into your sales reps, and we'll try to address as best we can. All right, so jumping right in, the steps into a good site assessment and getting ready, of course, is that pre-qualification and assessment. That's all the work you're going to be doing from the office or from home before you even get to the site for a proper on-site assessment. Then, of course, some of the steps that are important to get covered when you're on the site, making sure that your pre-qualification is accurate or updating and making sure we get that cleaned up. And then, of course, the last one is actually getting to work with the installation and going over a little bit of the products that we've put together, mainly based on the results of our survey that we did in winter last year. And I'll show you some of those products and some videos we've taken for them. All right, so how does everybody do their office? It's also great doing a pre-qualification or assessment allows you to represent with a good idea of the system you're going to install and the size, and of course be able to present something to your customers right off the bat. There's a bunch of different resources available to you. Of course, Google Earth is free. It's available to everyone. It's pretty good. I'm going to go into that a little bit. Local GIS programs. Most major cities and a lot of smaller ones now have interactive maps that you can log into online. Of course, there's all the pay-to-play software out there. We'll go into that a little bit, and of course, information that you want to get from these pieces of software is the idea of what the slope of the roof is, what kind of roofing material you're looking at, what kind of angle you're at, and using that information, get a good idea of what the system is going to produce. Jumping right in, I was looking at a site in Saskatchewan. At the top says the image is from 2015, so I took a look at a more recent image, and lo and behold, they've knocked down the garage, which was going to be would have been a pretty nice site for the installing the solar modules. That happened in 2017, and so that shows some of the problem. We've got a great clean image in 2015, but it's definitely not accurate in terms of today's install. So from that, I want to take a look and see what Saskatoon had in terms of GIS or interactive maps. And sure enough, of course, Saskatoon actually, it is called Saskatoon Interactive Map. You can search that and take a look. And it does look that on that roof, somebody has not only rebuilt the garage, but they put a solar project on it already. That's great. Worked out very well, and it looks like quite a nice install there. The pros for, of course, the interactive maps is the fact that they're usually local to the sites, the communities that you're looking for, and they're much more regularly updated than I found on Google Maps, especially in larger municipalities. As I mentioned before, the con is that they're not going to be in for all municipalities, especially more rural areas. That's going to cause you a little bit of problems in terms of finding finding good clean images. The benefit of all this, of course, is that both of them allow you to take measurements. As you can see from Google Earth, I took a measurement from the 2015 roof. We're going to ignore it from this moment on because it doesn't exist. But it just wanted to demonstrate that you can get measurements from Google Earth quite easily, quite quickly. As well, from the different GIS packages, you can measure your roof, get ideas of what the dimensions are like on a specific project. Continuing on with the Saskatoon interactive map, took the dimensions, looks like it's about 36 feet wide. I like to be a little bit safe and actually cut it down to 35, just for safety's sake. The accuracy of a satellite image can only be so tight. So taking that 35-foot setback and starting with a bit of an assessment, get an idea of what the customer can get on the site. Taking 18 inches off either side, as we recommend with all the fast track installations, and of course 24 inches down from the ridge. Our 35 by 16.5 foot roof quickly drops down to a 32 by 13 foot roof, which works very nicely with 72 cell modules. That's 2 rows tall and approximately 9 rows wide. 18 modules on site. That gets us, if we're looking at the QCell 400, a 7.2 kilowatt array. Quick and easy. This just straight off the bat took about 5 minutes to get this information pulled together. I've got an idea of the size of the system I'm going to get onto a roof. And haven't even left the house, get a good idea of what the customer is going to get. Sometimes you want to present more. You want to get a better idea of what you could get, what you can provide your customer in terms of not only the system size, but as well the production. And there's a lot of great tools out there. A lot of them are pay to play, so you're going to be purchasing the software. We end up at the moment, we're currently using Aurora for some of our modeling, and I know a bunch of dealers out there are also using it. But there is PV Complete, Helioscope, and PV Assist, as well as many other ones. We're not selling any of their packages, just giving you ideas of what's around for you. They all kind of act in a similar manner in that they give, by modeling the roof, adjusting the setbacks, you can populate based on your solar module size. They then take, of course, the local irradiance for that area, give a production estimate based off that irradiance, and give you a good model of what the roof can look like that you can get in terms of solar panels. And really nice perk of that is the ability to generate customized reports, something that your name can be on, delivered to site with that initial site visit. Cons, of course, it's pay to play. You got to put the money up for it. Sometimes it's a monthly subscription, some are annual, and some are just outright purchase. With all of them, the big thing is we all know the solar industry is constantly evolving, constantly changing, and so sometimes their product database can be a little bit lag behind, usually only by about a month or two, but be advised. So you may be having issues locating product. But quickly looking at it, this image over on the side here, using Aurora and mapping out the roof, and only again paying attention to the southwest facing slope. Modeled it out, set the 24-inch off the ridge, 18 inches off the sides and the bottom, and Aurora came out with 18 modules as well. So our doing it longhand using Google Earth was just as effective as for an initial site assessment as the pay-to-play program. the benefit of the pay-to-play program is this ability to not only put modules on a roof, but also to include inverters and optimizers, depending on what your system is going to be including. Calculating string lengths. I would always, of course, suggest caution whenever using something that's generating string lengths or making recommendations on how you're going to be wiring a system. It is make sure that it's accurate. Always double check, of course. But assuming that this is accurate accurate and the size of the array is correct, it looks like this 7.2 kilowatt array is looking at, based on the roof slope and angle, you can see it's looking at the irradiance on that roof is about 1,500 kilowatt hours per meter squared per year, or 1,500 sun hours. Gives you a good idea of what the system is going to produce, assuming no losses. But because we've added the inverter using Aurora and we've added the strings, the auto-generated report, which comes out of this nice and easy. And again, this is potentially something you could take to your customer for that first site visit. 7.2 kilowatt array, producing somewhere around 9.1 megawatt hours per year, and with 18 Hanwha modules, 18 P400 optimizers, and a 10 kilowatt inverter. Don't ever design a system this way unless you're planning on expanding the array in the future. This was me just quickly putting a sample together to give you an idea of what can be produced very quick and easy and taken to site. Little known secret, not too long ago we published the fastrack.ca website. We actually put this out there for really for homeowners to have a nice, easy first landing point when they're trying to find information about the solar and putting solar on their properties, their houses. And on that website, we have a link to allow customers to put in to request a free solar assessment. We ask general information, location, of course, contact info, and also ideas on what the utility rates are and what their annual consumption is. We then take that information, produce a very simple one-page report for them with an estimate on how many modules based on just the area of the roof, not doing any significant losses, shading, or anything like that, but just getting an idea of approximately how many modules, what kind of output we'd expect from that solar array, and what kind of savings they can expect. They get this nice single one-page report, as well as a request to see if they are interested in being put in touch with a local installer. That is our a little bit of a pre-evaluation on our side to give onto you, our installers and customers. But be advised, this is going on the local areas, so hopefully we're pre-evaluating customers in a specific region, and we're going to try to be fair to our installers in that area. So it doesn't necessarily mean that that all of the leads are going to go to any one individual company. But good to know that it's in the back pocket, and expect that you're probably going to get some leads from this as more and more popularity grows with it. Meat and potatoes. So this is actually getting your feet on the ground, getting on site, and taking a look and seeing how well you did with your site assessment, with your online or pre-site assessment, I guess, and confirming the information, making sure that that the system is how you expect it to be, or whether you need to update your expectations and notify the customer accordingly. As you can see, once you're on site, of course, confirmation of the roof type is important, understanding what your shades are, the dimensions of the roof, what your obstructions are, and understanding what type of loading we're going to be doing on the roof in terms of the weight of the system, as well as environmental loading. We'll get into that shortly here. First things first, roof types. A lot of our installs, obviously, asphalt shingle roofs are the most common roofing material in North America. So most of us are installing on asphalt shingle. If you get to site, fantastic. You know that you're going to be using the FR Talon or the FR Ultra Flash on those projects, and probably most of you have at this point installed the FR Talon, and hopefully you love it as much as we do. Corrugated metal roofs. We of course carry the CorruSlide product. It's designed to mount into the major ribs of your corrugated metal roofs. Also works for sinusoidal roofs, and it gains its capacity by biting into that trapezoid or that major rib. Standing seam roofs. The S5 clamps. That's definitely going to be our go-to for the foreseeable future. I don't ever imagine we would give those guys up. They have clamps for just about every profile out there, and I strongly recommend to all of our installers a nice little thing to have in your vehicle, in your kit. Metal shingle roofs. They have some popularity out there. The rubber shingles. Sorry, I'll correct that spelling error when we post this. Rubber composite shingles, and of course cedar shakes as well. They all require a little bit of special attention on how they can be secured down, and some of them, we're going to have to do some hunting to find a proper product for them. Sometimes that means, that means that there are occasional times when it's going to be in your best interest as an installer to reach out to the roofing manufacturer and ask them what their recommendations are for solar. Most roofing manufacturers out there have been asked that question already. They've got an idea of the product that they would like to see in their roofing material, and can make recommendations, save you a bunch of time, and then we can see about sourcing product either on our end and moving forward with your install. Various roof types. Other things about the site assessment. We talked about this a little bit earlier. Is of course using the pre-assessment, Google Maps, Google Earth, whatever you wish, to get an idea of what the roof planes of the building look like. But this is a good time for you to get on the roof, actually get some measurements, and make sure that you can get the system you want. Also important, of course, is understanding how you're going to get up on the roof. We've actually had a couple installs that were on the side of a cliff, and thank goodness for the site assessment, where we could actually plan ahead properly to get equipment up on the roof without having any special lifting equipment around. Of course, shading, near shading and horizon shading, that's important. I'll point out, for those of you who haven't met her yet, this is Steph. She's one of our sales reps in the Victoria office. This was taken on her first install, but most importantly, I just want to point out the giant amount of shade behind her here. Happened to be that this site had a tree that caused quite a bit of morning shadow shade on the array, but by about 10 o'clock it was always cleared off, and the system produced quite well. But keep in mind, if that's something that's going to affect the production of the system. Slope of the roof, of course, valuable in terms of getting good sun angles, in terms of in order to estimate the production of the system, and of course, with regards to the snow buildup on the array. The image in the bottom right here is actually one of my favorites. It's a project done by NATE, the Northern Alberta Institute of Technology. They built a solar array that actually has 5 different slopes on it, and 2 modules wide. What they do is they ensure that half the array is cleared off, the other half they let nature do its job, and the goal was to see what happens with snow on roofs, as well as what happens with production, annual production when you just let snow cover happen. Ended up being losses were between, I think, 5 and 12%. I'd have to confirm those numbers, but they're quite low, and so the snow isn't a big issue in terms of production losses, but there's other concerns with regards to snow, which we're going to get to in just a moment here. Of course, the next part, when you're on site doing your assessment, one, get your sketchbook out. Start getting all your dimensions. We've all, I'm sure most of us have been to a site, thought we got all the information we needed, and then of course realized that we didn't mark out where a couple of our roof vents were, and that leads to concerns when it comes to time for the solar install, whether we're going to have interference with our modules and or racking. So can't hurt, measure everything, every obstruction that's up there, get a good idea not only of where it's located, but actually what the obstruction is. The amount of times I've seen sketches that come in that indicate there's something on a roof, but doesn't indicate what that something is. I'd say almost on a weekly basis we get that kind of information, and it causes delays with speccing projects and getting your systems out to you. I can't stress enough how important it is to take pictures of everything. Pictures of the roof, pictures of the access, pictures of the horizon. This place just happens to have just a phenomenal view off the top of the roof there. And this is just a little north of Victoria here. And of course, confirming dimensions, but see how accurate you were with your pre-assessment. Get those tightened up, get a more accurate idea of what your array is going to be. With all that information, once you've got the roof planes measured out, you've got the obstructions located, your slope, understanding how much room you've got available. Now's the time that you can go out. This is easy to do with a pen and paper. Looks a little bit nicer, I feel, if you can do it in some type of CAD program. Google SketchUp is free. It's an easy one to learn. It's definitely worth looking into. Otherwise, definitely with Aurora and PVSys, and I believe PV Complete, I'm sure I can with PV Complete, you can actually put in your individual dimensions and populate the roof array accordingly. Once you've got an idea of what you're going to get in terms of modules on the roof, in terms of what your rows of modules are, definitely visit the Fast Track component generator on the hspv.ca website. The link's on the right-hand side for you to write down, and you'll find it online when this gets posted online later on. You can put your details of your modules, how many modules, what rows you're getting, and you get a nice clean list of components that you'll need to send on to your sales rep in order to order your product. Makes quoting a heck of a lot easier, saves you a bunch of time and potentially missed components. Of course, when we change the size of the array, when we've confirmed that we've got our module count accurate, this is a great time to again rerun your production estimate to see if there's any changes based on any changes of the system size. I mentioned loads, environmental loads, and so wind loads, of course. The image here is one that I put up there because it's not stressed enough how important it is to take in mind how wind loads affect ballasted solar arrays and not properly designed ballasted systems. Not so much a big issue for our flush to the roof, sloped roof installs, but anything that's tilted up from the roof that allows air to flow under or around it, it's important to note. And of course, snow loads. More important with the flat roofs again, in terms of solar arrays causing a little bit of damming, causing some drifting to occur, and potentially increasing the snow load on the roof of the building. Sloped roofs, generally not a problem because the makeup of the modules, the glass surface that they are, you generally make them better at shedding snow anyways than the shingle roofs that they're being installed upon. Glass and metal, of course, both being quite smooth, so you are getting rid of a lot of snow on both with a solar array on a metal roof or just a metal roof by itself. So again, not a big change to the snow loads on sloped roofs. I'm going to just touch briefly on the image in the top right. This was an install that happened that the customer decided that they wanted to do their own ballast plan, and unfortunately did not work and did not get warranted, and was potentially hazardous. Thankfully, I believe they got it resolved, but we do offer ballast plans, engineering sealed documents giving accurate ballast locations. I strongly recommend you take advantage of those for your ballast systems. Want to talk a little bit more about wind loads, how we actually get what the actual wind load is. I'm not going to go into a long discussion on the National Building Code. It reads just as well as the Canadian Electrical Code, which is dry on both counts. And but determining wind loads is not just as easy as looking it up in a book and figuring out, oh, my wind loads for this site is X. It takes in a lot more information than that, in addition to the physical location of the install. But it also does have a scaling factor based on whether the building's an unoccupied building, like a shed, your house, which is generally a small population building, a larger population building like an apartment building or business or office building, and then post-disaster buildings which are expected to be at least standing and partially functional after a large environmental issue, such as an earthquake, schools, fire departments, that kind of thing. And so there's a scaling factor with regards to that. Exposure, whether you're in a rural area or an urban area or some kind of mix between buildings and open land around. Those all affect how the wind acts on buildings. Just like a building, a hill or escarpment can also cause wind to accelerate, causing greater uplift on buildings located on the top of hills or close to escarpments. And then the shape of the building, flat roof buildings versus sloped roof versus gable or double hip roofs, and on and on and on. There's a whole bunch of variables that are involved in there, and the size of the building as well. This is quite a convoluted task, but again, for your sloped roofs, most of the time this isn't relevant. It is very important for any ballast plans. Just like the wind loads, snow loads, similar section of the building code, dependent on location, what type of building it is. Again, the occupancy of the building, the shape of the roof, how large it is, how much it's exposed to wind. Of course, the more wind that blows across the roof, the less snow you're going to have on it, but it also does affect the potential for drifting, building up snowdrifts on the roof as well. I did want to do a quick example. This is a generic building for a generic building with a flat roof in North Vancouver. Took a look, and the ground snow load at the site. This is just, if you were just measuring how much snow accumulates over on the ground, is of 3 kilopascals, and the amount of moisture retained by that snow is 0.3 kilopascals. Unfortunately, that does not mean that our site snow load is 3.3 kPa. This is the variables come in. Knowing that this was, assuming that this building is a warehouse with a big flat roof, the importance factor of it would just be considered normal, and so it gets actually a little bit of a buffer. It drops down to 0.9 as opposed to using the full value. The size of the roof, because of the area of the roof and its shape, again, this snow load is actually decreased by a factor of 0.8. The shape of the roof, again, flat, nice and easy. Exposure to wind, assuming it's just a generic building, doesn't have any obstructions on it, doesn't have any parapets, scaling factor of 1, and with no parapets, you don't get any accumulation. So where we started out looking at potentially a 3.3 kilopascal snow load, it actually drops down to 2.43 kilopascals. That's going to be important when we start looking at modules and compatibility with snow loads. and mounting points. That's come up with a couple of different projects over the last couple of years. And so this is just a little bit of background as to how we get the values we use. On with the site assessments, very briefly going to touch on live loads versus dead loads. Dead loads, nice and simple, means stuff that stays on the roof. If it's a permanent attachment, if it's an HVAC unit, the solar array is, by nature, is a dead load. It stays up there. And then, of course, the live loads are things that are variable based on the occupancy of the roof, temporary things, such as the installation team. For those who haven't met me yet, I am that large guy up in the top right of your screen right now, with my fall arrest gear on, and demonstrating our fast rack tape, which we're going to talk about very briefly in a moment. When we look at dead loads on a roof, on live loads on a roof, there is the building code requires a minimum value, or else it is usually designed to the roof snow load, because in Canada, our snow loads are significantly higher than the minimum expectation from the building code. Side note, for those people installing on shingle roofs, most shingle roofs are designed with an extra 5 pounds per square foot available capacity, which is approximately the amount of weight added by installing a second layer of shingles over the first. Because our PV installs on flush roofs are generally under 4 PSF, this is a great point that we like to make with the building departments, to let them know that if there's only one layer of shingles on the roof, it's generally safe to assume that the roof has the capacity to install PV array without any requirement for additional building permits or engineering review. Big note, this is assuming the building is built to current code and is in good repair. If it's an old rackety shed, you might be in trouble. Moving on, this is the last section. Thank you. I'm going to quickly go through this, but thank you for attending so far. The installation, nothing saves time quite as much as pre-assembly. The more work that can be done on the ground, the quicker your install is up in the air. I like to, when I get to site, have somebody assembling rails while somebody else is marking out where the feet are being located. Assemble full lengths of rail to the best of your ability. Mount your inverters or optimizers or microinverters. Start getting that all done as quick as possible on site. Unfortunately, yeah, there's no glamour in pre-assembly, so nobody wants to ever take a picture of it. There's no action shots there. Now, mentioned the fast rack tape. What we've done is last winter, we put out a survey to our customers and asked what would make your guys' life easier? What would you like to see us improve on? And one of the big requests was helping with the initial layout of the array. And that, to help with that, we put together a couple of products. And the first one's the fast rack tape. I'm going to play a video here. The audio, I apologize, is not going to come through. But the fast rack tape, it's nice soft tape, easy to crumple up, throw in your toolkit while you're traveling to site, secure it up at the top of the roof, give it a bit better of a throw than that. But what we've got is these red marks that you'll see just kind of in the bottom left of the screen on the tape, which measure out where you're going to want your rails to be sitting for 2 rows of rails. So marking out the location for the top, the course of shingles for the top rail of the top row, bottom rail of the top row of modules, and so on as we go down to the second. Nice and easy, makes your guys' life, makes the install a little quicker, just marking out which row of shingles you need. Saves time and saves people trying to figure out, calculate where they want those to be. And there we are, I'm going to jump on from that one. So that's the fast rack tape. It's available from all of our warehouses. I believe all of our warehouses. If not, they're small, light, and can ship from anywhere. Other product, we recently came out. We had as a result of that survey, people wanting easier ways to move product around the roof. We've all hung a bucket off the side of a roof. Great if you've got a spare set of hands, a bit of a pain if you're climbing up and down the ladder just to fill it and hoist it up. So we came out with the fast rack bag. Anybody who was letter carrier or delivered papers as a kid, probably will recognize the design and recognize the benefit of it. I'll just quickly show this second video here. I'm not going to let the whole thing run through, but in it we have. I'm just going to jump ahead. Pardon me for a second. Into this bag, we actually managed to get a full box of the fast rack talons, 25 talons, 25 flashings, the screws necessary for it, and of course the impact needed for the installation. Convenient. We did design it so the strap wraps all the way around, so it does have the capacity to hold the modules. Nice, goes over the shoulder, and good for getting up on the roof without fighting too much with your gear. End it at that point and continue on. The fast rack bag, great product. Saved a ton of time on a couple of our test installs, and yeah, the people who've used it so far have been very happy with its function. Now the big ones, which everybody really does care about, we have a product out, the Fast Track screw, or FR screw, in your price lists. It is a box with 250 1.5-inch number 10 metal screws. 250 because that is the quantity you're going to want to use for a box of the Fast Track talons. Order a box of the talons, order a box of the screws, you're ready to go. 1.5 inches, we settled on that length as it is a good length for penetrating a row of shingles and getting into a sheathing, even if you have to get even if there happens to be some insulation in between. Then we've had a lot of questions about metal screws. Why do we spec metal screws? The reason for that being is wood screws usually have an unthreaded shank up near the head, which is exactly where we want to be biting into the sheathing with our Fast Rack talon. Despite being called a metal screw, it is designed to be screwed into wood. The metal portion just means it's also designed to be able to punch through sheet metal. So if you had a metal roof, you could actually, using these screws, get through it. Don't recommend using Fast Rack talon on a metal roof, but just that's the reason for the screw. The other one, and this should make a lot of people's lives happy, because this was about 80% of our recommendations, was to make the Fast Rack mid clamp easier to install and a hands-free installation. So we did. We came up with what's now going to be the Fast Rack MIGS, and that is it's our spring-loaded mid clamp. It is based off the original design of our mid clamp with the integrated bonding, but it also comes with a very easy to install spring and flange here. As you can see, easy to operate just simply with a thumb and a couple fingers. Slides into the rail. Once it's in place, the spring is going to push down on this bent metal plate. That's going to hold the mid clamp in place while you get your modules lined up and secured. Again, sticks with the original design of our mid clamp, so you still get that listed bonding. At that, I've gone a little bit over on my time, but we will still open us up to any questions that may come up, and otherwise, do write into your sales reps, and we'll try to address them as best we can. Thank you all for attending, and I'll open it up and wait for Cameron. We'll give everyone a couple seconds to type in if they need, and then we'll go from there.
Awesome. Thank you very much, Dan. That was really well presented, and lots of really good information in there. If anybody does have any questions, feel free to pose them right now in the Q&A section. Or if you do have questions that for after the presentation, feel free to email your reps, and we'd be more than happy to answer them. Thank you very much for attending today, as always. One quick thing, I believe there, as far as availability goes, some of these products that we're talking about right now are just coming into availability. So do check with your reps for the availability, as they are all just being, I believe, delivered across the country. Dan, it looks like you've nailed it, because I don't see any questions right now. So well done. Thank you very much for joining us, and thank you, Dan, for the presentation.
Thank you all very much, and it was my pleasure, and look forward to seeing you all back, soon.
All right, guys, everyone have a great day, and yeah, get up there on the roofs. Take care.